are the suspension and brakes team.
My name is Cole Shive.
My name is Kenneth Daniels.
I'm Hunter Flowers.
I'm Patrick Bolton.
I'm Ethan Watney.
Alex Erickson.
I'm Trevor Stroud.
Formula SAE is an international competition where colleges compete by building a race car that applies to certain rules and guidelines. And this year, the Formula SAE competition will be in Michigan in May. Our subsystem's goal this year was to design and build a full suspension and brake system for Ram Racing's competition car so that we can compete this year.
These 8 customer requirements were given to us by our project sponsor, Ram Racing, or derived from the FSAE rules and guidelines.
One other main component that we're in charge of with our subsystem is the steering system for the car. Fortunately, most of the components of the subsystem we were able to reuse from past years, which really helps with the performance specification of keeping costs exactly where we want it to be. Also, with the steering system, we have a target steering angle in degrees of 33, plus or minus 1 degree. So in order to test the steering angle of the car, we basically took a compass app on the phone and laid it right up next to the upright of the car. That way, when the driver inputs the steering through the steering wheel, we could see clearly what the output was with the wheel angle. We retested this in multiple locations to account for any compass error that might have occurred. And fortunately, there was no significant error and we were right on target.
So another performance specification that we had was our dynamic camber change. This is a targeted specification with an upper limit of 5 degrees plus or minus 1 degree and a lower limit of -4 degrees, also with a tolerance of plus or minus 1 degree. Alright, so this is an upright installed on the car here. It serves as a mounting point for the main outboard suspension, meaning suspension outside of the chassis. It has a bracket here for our upper ball joint of this control arm and mounting point for our lower ball joint of the control arm, as well as mounting point for our steering tie rods and mounting for our brake calipers. And it also houses our central wheel bearing held in by a retaining ring. So camber angle is the angle with respect to the ground that this face of the upright sits, meaning if the car is going straight at neutral steer, this face of the upright is going to be at 90 degrees. Now, dynamic camber changes this angle with steering input. So if I steer the car inside, this face of the upright is going to be angled in kind of like this, giving it negative camber. So this is our target of -4 degrees. And then when I steer the car out, this face will be angled out like this, giving it positive camber, which is our target of 5 degrees. By having this camber angle change, it accounts for that deformation. So we'll have maximum contact patch with the tire in the ground. And when we're, say, going through a straight, when it's at 90 degrees, we'll also have full contact patch with the ground. So this dynamic camber really allows us to have maximum grip at all times.
So this year we needed to design suspension components that could withstand the forces of driving without deformation. And in order to tackle this task, we decided to do a full spindle redesign. And this means that the spindle must be able to withstand a bumping force, an acceleration of around 3 Gs and a turning acceleration of about 1.5 Gs. And in order to compensate for that, we needed to settle on a material that would have enough strength that the spindles could be manufactured out of. And thankfully, we've been gifted the opportunity to receive a sponsorship from Woodward so that they can supply us with the manufacturing and EDM cutting, which we'll get into later, for the spindle for this year's drive feed competition. So I present to you here the spindle. This is from a previous design, from a previous iteration of the vehicle. It is placed here into the upright where there's a wheel bearing, so it gets pressed into there. And here is the brake rotor section where the brake rotor is held onto, and then so it can integrate here with the brake caliper and the brake pads. And then here you have the lug holes for the wheel so that it can get bolted onto the spindle. Okay, so for this year's redesign of the rear section, we needed to integrate the spindle to a smaller wheel bearing. So for this, we needed to redesign the spindle with a smaller diameter to meet in with that wheel bearing. As you can see, this one's a little too large. And also, in order to integrate the spindle to the drive shaft, this tripod will be used to mount the spindle through this section here, kind of like that as an example. It'll be bolted on, and then the drive shaft will mount with the tripod, and the spindle will be able to be driven by the engine. So in order to test for our material strength values for our spindle stock, we wanted to verify the hardness as compared to the as-received hardness values. So we used this device here, which is a Rockwell hardness tester.
Our next performance specification is the total cost of the suspension and brake components on the vehicle. The goal for this was to keep the total cost under $5,000. This was achieved through careful selection of components, comparing quality to performance, and selected as such. A cost report was done pre- and post-manufacturing to make sure we were still on track, and our current total is $3,400, which falls below our limit.
Our next performance specification is added suspension roll stiffness. Our target value is 6,000 pound-inches per degree. This was achieved through the use of a Z-bar type anti-roll system, which transfers load between the sides of the rear suspension through the use of a bending bar attached to both belt cranks. There is a spherical bearing as the mounting point in the center of the Z-bar, which allows the bar to swivel throughout the full travel of the suspension.
So once we have the spindles and are able to mount the wheels to the car, we will be able to carry out our roll stiffness test. This will consist of pinning the chassis using these jigs to the bottom of the suspension tabs, so as to restrict any rolling movement and to measure the load transfer between the rear tires when the sides of the suspension are unequally compressed.
Another performance specification for our braking system was the brake torque values. For the front rotors, the target range was 200 to 300 foot-pounds, and the rear rotors was a range of 45 to 65 foot-pounds. To create these torques, we controlled the rotor diameter as well as the caliper clamping force to produce the optimal braking.
Our next performance specification is the brake temperature. This is a targeted specification with an optimum range of 500 to 700 degrees Fahrenheit for all 4 of the brake rotors during the endurance event, and this led us to make decisions for our material for the brake rotors.
This is the driver interface for the brake system. When the driver presses on the brake pedal, their force from their foot is transferred into the master cylinders, which creates a hydraulic pressure in the front and the rear brake lines.
Which then reaches these nice Willwood brake calipers, which creates a braking torque to stop the car.
The pedal box is also mounted to adjustable tracks that provide 1-inch increment spacing so that the pedals can be moved closer to the driver for shorter drivers. For our brake torque test, we'll attach the rotor to the spindle, and then using this snap-on torque wrench, we'll apply a torque to the spindle, and while the driver is pressed down on the brake pedal, we will increase the torque values until the rotor can break free of the calipers, and that's when we know what the maximum torque is supplied by the brake system.
Alright, so in all, we came under budget for our entire suspension system. We also learned a lot this year that we're going to be able to pass on to next year's team. We are on track to competing at Comp in May. Yeah, come check out our booth at E-Days.
We would like to thank all of our project sponsors for making this FSAE vehicle possible.